few more big breaths, and then you block it, and then you stick it on here, and then you make a hover track. And you can take it home real quick. Watch this one. Let's see if they'll land perfectly straight. Let it go.
They cause a color change. So, like potassium kind of creates a purple flame when excited. Copper, kind of like a greenish blue. Let's see here. We got some calcium, kind of like a orange, a little bit of red in there sometimes, and then lithium. The struggle is real today. I'm sorry for this. We're having meltdown.
And what's cool is the dry ice is more dense than air, so you can actually record it. Oh, look at that.
Was it a
price, and maybe they could enter it in the army and put a stick of dynamite in it?
what? Shooting frisbee?
Yep. Last year there were 2-foot diameter tennis balls. And the idea was to pass it to your allies and then score it in the goal.
And they have to catch it?
Yeah.
Chicken though, right?
Brain. The chicken smell worse. Oh, I'm picking up a brain. Oh, I thought I'd never do this.
Oh,
Oh, gosh.
Okay, and then to that, I'm going to add a little bit of potassium iodide. So what this is going to do is it's going to break down the hydrogen peroxide and release the oxygen. So hopefully this works. Looks a little bit like toothpaste. First try, yeah.
Wasting money.
then it's fun. There we go.
So it's a volcano.
We just like fire.
There's no way to sugarcoat it.
And a lot of the composition of it is nylon. It was one of the greatest findings that we had around 1930. And so you can actually create it just using two simple chemicals. It creates a polymerization reaction, which just means you get a lot of bonds. you guys can actually see, start walking around, there's a split between the two different liquids. And right where they're touching is actually where that nylon is forming. So if I'm capable, which I'm not, I will...
Capable.
So that's nylon, it's just not cooperating. So basically all we make is
Oh, you missed.
Bryson.
Oh, they locked it up.
But you can hit it, and that's where you're
Oh my goodness.
No aim.
Come on, Hunter didn't get a lot of lunch today. He's hungry.
Looks like a bad teenage boy.
Oh, you need to sit down. Rookie
You gotta
mistake.
close.
Do you think you can catch it?
Try it again.
And move back.
I don't think it's gonna come out that fast.
Inside of it, and we capped it with Mylar is at the end. And I'm going to turn on our vacuum pump and suck all of the air out of it. And then all of the air outside of the, okay, out of the tube is going to be pushing on it, trying to get in because there's no in here. Or, yeah, there's no pressure in here and there's more pushing in on the outside. So then we're going to stick a hole in the end, and that's going to put all of the air inside of it and push the ping pong at that thing. And we're going to try to hit the cardboard, hopefully. You messed up the wall. This is the wrong way.
It's not the kind of question you want to
Matthew has it. He wants to shoot it.
People don't need to put them in. No, don't. Please don't. Please don't.
They know.
Please don't. You're in.
I turn it off and then close it, or just close it and then I close it and then turn it off.
Okay.
Are you ready?
No, it's very loud. Okay? It's quite a loud bang. So cover your ears if you don't like loud noises.
Alright, go for it.
Cover your ears, Walker. Oh, Christ, where'd it go?
Big heat can, and all of it's put. When you heat up the water, it pushes all the air out, and it's all filled with water vapor inside the can. And we're gonna take it off and submerge it in colder water and see what happens. So, enough explanation of this? And I think it's easier if you hold it upside down. Yeah, go.
They got a little too much water. Here, try another one.
Upside down. Like that.
What's it supposed to do?
Ready? So crush the can. Does anyone know why? I don't know who said that.
Pressure.
Why do you think?
Decompression.
Watch out.
Mine was the best.
Seal it up good.
Oh wow. That was so sad.
All right. We'll move on to other stuff. We'll set it up again and try to do another one. All right. Here it is. I'll just show you right off the bat. Slip a metal ring over this and flip the switch. There we go. All right. So what's happening here is we actually have a coil of wire down here, very large coil of wire, and we're putting a very high current through it. It's coming out of the wall. Okay? So when the current flows through a coil like this, it turns it into a magnet. It's called an electromagnet. Okay? So there's a magnetic field pointing one direction, kind of like a bar magnet or south. When you have this ring over top of it, and you generate this magnetic field from this electromagnet, it actually creates a current in this ring, which is sitting out here in space, and as the current builds up in this, it turns it also into a little electromagnet. But the magnetic field produced by this electromagnet point in the opposite direction, so they repel each other, and this launches the ring up off of the pole here. Okay? That's basically what's happening. So that doesn't happen with just have that, okay. With just anything. If I have a ring that's cut like this, right? The whole idea, remember, is that you're getting a current flowing around in this ring, making it into a magnet that repels this other magnet down here. If it's cut, yes, you can't have a current flowing in it, okay? So it doesn't do anything, okay? Okay, so we're going to try this. Shake your head side to side a little bit. What does it feel